Hey guys, it's Danny here from Disrupt Tutoring, and as always, it is a pleasure to join you. Today we're going to do a chemistry multiple choice question from the November 2019 Grade 12 Physical Sciences, Paper 2. This question deals with an investigation to determine how certain factors affect the reaction rate of the reaction given by this balanced chemical equation. To do this, the amount of carbon dioxide produced is measured for two different types of reactions. Firstly, a single lump of excess magnesium carbonate with a volume of 100 centimeters cubed reacts with a hydrochloric acid solution with a concentration of 0.2 moles per dm cubed. The amount of carbon dioxide produced over time is shown by graph G. Secondly, magnesium carbonate powder, also with a volume of 100 centimeters cubed, reacts with a hydrochloric acid solution, this time with a concentration of 0.1 moles per dm cubed. The question then wants us to identify the curve of carbon dioxide produced over time associated with this second reaction. So there are a few things that affect reaction rates. Firstly, the nature of the substances. Some substances are simply more reactive than others. The surface area of the reactants. The higher the surface area, the faster the reaction will proceed. The concentration of the reactants. The higher the concentration, the faster the reaction will proceed. And finally, the temperature. So, between the first and the second reaction, two of these factors are changed: the surface area of the reactants and the concentration of the reactants. In the first reaction, a single lump of magnesium carbonate is used, whereas in the second reaction, a powder is used. This means that there is an increased surface area of reactants in the second reaction, and this will increase the rate of the reaction. Likewise, the concentration of the hydrochloric acid is halved between the first and the second reaction. So this will decrease the rate of the reaction and also decrease the amount of carbon dioxide produced. So let's keep these in mind while we look at our options. We're looking for a curve with an increased reaction rate, but also a decreased amount of carbon dioxide produced. Curves A, B, and D have a faster initial reaction rate than curve G, and that is shown by the steepness of the curves. But only C and D produce less carbon dioxide than graph G. So from that we can see that D is our answer. And if we compare G and D, we can see that the powder reacts much faster than a single lump. So here at the beginning the curve is steeper, but reaction D produces exactly half of the carbon dioxide produced by reaction G, which is what we're looking for. So D is the answer. Before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time,